So this is a movie that's going to review the rules for significant figures. The reason we have to make sure that we use significant figures in science is that we have to make sure that our measurements are accurate and precise. If we take a reading on a ruler that is 17.5 centimeters, and then I use another ruler and I only have 17 centimeters, I have to make sure that my answer is only going to be to the correct number of sig figs. So let's talk about how you're going to figure out how many sig figs there are. So first rule is that all non-zero numbers are significant, meaning that they are going to count as sig figs. So you can see in the examples here that we have 613, and with 613 it has 3 sig figs. So the 6 is significant, the 1 is significant, and the 3 is significant. If I have the number 123,456, that has 6 sig figs to it. So any number that is not a 0 is always going to count as a significant figure. It gets a little bit tricky when we get to zeros. Okay, anytime we have a 0 located between non-zero digits, they're going to count. So in the example here, we've got 5,004. Those zeros count because they are between non-zero digits. So that number has 4 significant figures. If I have 602, that has 3 sig figs. The 0 counts because it is in between 2 non-zero digits. Now, if I have this big, huge number right here, there's no decimal point. It's in between 2 other digits. As long as all those zeros are in between 2 other digits, they're all going to be significant. All those zeros there will be significant. So this one has 16 significant figures. Now, trailing zeros. This is where zeros become tricky. They are going to only be significant if the number contains a decimal point. If there's not a decimal point, they don't count. So, looking at the examples here, we have 5.640. It has a decimal, the 0 counts. So we've got 4 sig figs. If I have 120,000 and I put a decimal point at the end, those zeros are all going to count. It's almost like that decimal point right there counts as like, yes, hold everything in, we're going to count those numbers. But the same number right here, if I don't have a decimal point like I did up here, okay, that same number without a decimal point only has 2 sig figs. The decimal point makes the zeros count. The fact that there's no decimal point at the end, it's not like the bookends. It's not holding all those zeros in. So those zeros fall off the back end. Okay? So, one more rule that we have to make sure that we're careful about. Zeros to the left of the first non-zero don't count. So zeros to the left pretty much never, ever count. Doesn't matter. So if I were to put a bunch of zeros in front of this and put 005.640, those zeros there, they don't count. Okay? So these zeros right here, even though there's a decimal place, they don't count. Same with this one. Even though there's a decimal place, they don't count. This one as well. All these zeros, they don't count. Okay? So, key rules to remember. Non-zero numbers are always significant. So any numbers 1 through 9, anytime you see those numbers, they're going to count. Zeros get a little bit tricky. If the zeros are between 2 digits, they count. So 109, the 0 counts. 5,008, the zeros count. Okay? Trailing zeros. If a 0 is at the end, if it's to the right, it only counts if there's a decimal. Okay? Key there, only count if there's a decimal on the right. If the zeros are to the left, and they're not in between another digit, if there's no digit in front, okay, there's no non-zero number in front, if those zeros are to the left, they never, ever count as significant. Okay? Next, let's try some practice together. Take a second and think, how many significant figures are in 48,923? All of these are non-zero digits. You should say 5. Every single one of these non-zero numbers count as significant. Next, take a look at 3.967. How many significant figures are there? You should say 4. Every single one of those is a non-zero number, so they count. Now we get some numbers that have zeros included, so we're going to get a little bit trickier. Decide for yourself how many significant figures are in 900.06. You should have said 5. We're going to follow the rule that these zeros count because they are sandwiched between two non-zero numbers. It's like they're holding them in, and those zeros are going to count for us. Take a look at the next number, 0.0004. How many significant figures are there? You should say 1. Although there is a decimal point, there's no number in the front to hold these zeros. So all zeros to the left do not count. Okay? Zeros to the left don't count unless there's another number over here to hold it in. Try the next one, 8.1000. This is probably one of the trickiest ones. Zeros to the right do count if there's a decimal place. Since there is a decimal place, we have 5 significant figures here. The next one, 501.040. There's a lot of zeros in here to consider. So first thing, does this zero count? You should say yes. It's sandwiched between the two of them. The next question, does this zero count? You should say yes. It's sandwiched between two non-zero numbers. Does this zero count? You should say yes. It's to the right with a decimal point. So I do have to count it. So this actually has 6 significant figures to it. Finally, try the last one. First thing you should decide, do these zeros count? They do count because of the decimal point, and they're to the right. That's the key. To the right, decimal point holds them in. So you should say there are 3 significant figures here. Next, we have to understand rules when we are adding, subtracting, multiplying, or dividing. This comes into play when we're doing things like calculating the area of something or calculating the volume of something. So, the rules for addition and subtraction. Your calculated value must have the same number of digits to the right of the decimal point as that of your least precise quantity. So, if we look at this example right here, 7.939 plus 6.26 plus 11.1. First thing we need to do is decide which one has the least number of decimal points to the right. So, we've got 3 decimal points to the right, we've got 2 decimal points to the right, and we've got 1 decimal point to the right. So, that tells us that we can only have 1 decimal point to the right. We have to go with the least precise. So, when you go ahead and plug this into your calculator, you end up seeing that there is an answer of 25.299. The problem with that answer is that 11.1 only has 1 decimal point to the right. So we can only go to the tenths place. So we have to round that number, and we would round it up to 25.3. We'll do a few more practice with this before we look at multiplication and division. Let's take a look at this next example. If you were to take 5.3 and add 2.986, you get an answer of 8.286. Again, first decide what your least precise number is, the least number of decimal points or decimal places to the right. That would be right here, our tenths place. This one goes to the thousandths, so that's too many places. So we can only go one place to the tenths place. So I have to round to this digit, my tenths place on my answer. So the answer of 8.286 is actually going to be wrong on a test. You have to have an answer of 8.3. I have to round that 2 up because of the 8 right here. So the correct answer for that problem would be 8.3. Let's take a look at another example. Here I have a problem of 125.286 plus 3.55 plus 9.64. If I plug that into my calculator, I get an answer of 138.476. First thing we need to decide, how many decimal places will my answer have? Well, 3.55 and 9.64 go to the 100ths place. Therefore, my answer can only have to the 100ths place. So I can only go to this place right here where the 7 is at. So since I can only go to the 100ths place, I have to fix my answer to be 138.48. I'm going to round the 7 up because of the 6 right here. So the correct answer is 138.48. The last item is scientific notation. Scientific notation basically means that we're going to change the number to between 1 and 10, well actually 1 and 9.999, and then we're going to take it to a power of 10 to make that number. So for example, if you look at number 4 right down here, 9,256, we're going to change that to 9.256 to a power of 10. So we want it to still be 9,256, but we want our first number to be between the numbers of 1 and 10. And so we've moved the decimal point 3 places. And so in order to make 9.256 9,256, we would have to multiply this number by 1,000. And so that would move our decimal place back over to here. So 1,000 has 3 zeros in it. So that's the same as saying 10 to the third power. So in order to make 9.256 the same number as 9,256, I would have to take 9.256 and multiply it times 1,000, or 10 to the third power. Now, if I want a really small number, like number 5 here, I would be putting it to a negative power. So that means that I would be moving my decimal point to the left, or basically 10 to the negative third power is like dividing by 1,000. Okay, so if I were to take 2.05 and divide that number by 1,000, all I have to do is move the decimal point, the 3 placeholders, so I would move it 1, 2, 3, put a dot in, and then put zeros in front of that. So it would be 0.00205 is the same number as saying 2.05 times 10 to the negative third. So don't worry about trying the rest of these up here where we're doing multiplication, division, and subtraction yet. What I would like you to do is look at number 6 and so on, how many significant figures there are, and then try to write the number in scientific notation. This worksheet is on Schoology.